Hey, okay, so let's take a look at a project that I've been working on off and on for the last year as interest really happens. Anyway, so this is a real-time clock or the clock chip replacement for with the old Sun Blade or the Sun Microsystems computers. They used see the M48T59Y. Okay, so this is the data sheet for the original clock chip. As you can see, the original chip was this 28 pin DIP chip. That's DIP is dual inline package, I guess. This has a embedded battery inside of it that eventually drains, as batteries do. And once the battery's dead, well, the chip isn't really much good unless you do some like major surgery to like cut open the potting material that they've filled the chip with. Basically, unless you're prepared to go cut the chip apart and solder in a battery replacement on this thing, well, that's kind of the end of the road for that design. Now, unfortunately, as you can see, ST Microelectronics, they have they've stopped making this particular chip. Okay, you can see obsolete product. Now, it's important to note that it's unfortunate that Sun Microsystems kind of cheaped out on the on their chip choices when they designed the Sun system boards. What they could have done is that you could have used this system down here. This comes with a ST branded replaceable battery and crystal. And yeah, we had they used this variation of the chip, well, then we would we'd be able to replace our batteries. As it is, yeah, because they didn't use this system and they used the one with everything all in one, well, the consequence is that as the battery dies, the whole chip becomes pretty much useless. Uh, Now, because this has been obsoleted, I think for it's a number of years, may even be about a decade now. Pretty much all of the old inventory that's been sitting on shelves, even if it was brand new, there's a really good chance that the batteries in all of the stuff is just starting to degrade. I don't know what the shelf life of the little lithium ion batteries that they would have put inside of these things is, but it's not forever. So we need a replaceable battery solution. Now, I'm gonna catch everybody up. I have been working on this project off and on for a for a while, and so this is the let's say this is revision. What are we on here? Uh, Revision 4. Yeah. Okay. Yeah. Revision 4. I've actually built and designed is perhaps yeah. I've designed a replacement. Um, for this clock chip a couple times using more modern or parts that are still in manufacture. Okay, so this is my current design as of revision 4. We're going to be using the M48T37. Okay, we're going to use the 5-volt variant of this, so it'll be M48T37Y. And my design is pretty straightforward here. I had to draw the schematic symbols into KiCad, but basically, the original device had 12 addresses. Okay, it was just a what is it, like 8 kilobit of memory or something like that. Maybe a 64. Anyways, whatever. It just had 12. What is 2 to the power of 12? I guess it's 2 to the power of 13. Hey. I don't remember. 13? Yeah. It's 2 to the power of 13. So it had, the original one had 8K of addressable memory. This newer, or this variant of the clock chip has, it has, as you can see, an extra 2 addresses. So that will be 15 K, no, sorry, not 15K. I think it's 32. 2 to the power of, what are we doing? 15, yeah, 32. So this one has 32K of RAM, addressable memory. Now, the way this chip works, it has, um, let me see here. It has basically you have an address that you select with your pins on the left that we've got selected here, and then you can either pull data out on the right out of these pins on the right with either the output enable that'll allow us to get data out of the chip, or we can put it into write and we can send data in. So these are actually bidirectional pins, the DQ pins on this side here. That's all well and good, but because we have more addresses, we're going to just pull two of them hot, and we're going to do what is it, the most significant bits? Yeah, are going to be, we're going to set them to 1 permanently, so we're just going to set them to 5 volts. So I have worked on this device a few times. The first revision, basically, I hadn't actually looked, for some reason, I'm not entirely certain why, I hadn't looked at what parts were from the original vendor. And when I went looking, I found that the original chip, yeah, the M48T59, this one, although it's no longer available, pretty much all of the various manufacturers that uh, made these similar clock chips, they all like invalidated their 8 kilobit addressing at the same time. And so my suspicion is that they have an upstream supplier that was doing like even from these various vendors that had was manufacturing these things. And yeah, and when they invalidated this, all of the compatible vendors or comparable vendors, I think TI had one, Dallas Instruments had one, there may have been others. All of those vendors stopped distributing at the exact same time, more or less. Well, not exactly, but pretty much at the same time. All of those vendors stopped distributing semi-compatible chips. Now, there is still chips that I believe are somewhat compatible, and this is one of them. And I haven't tested this, but I have examined the datasheet pretty thoroughly. We can actually do that right here. So this is a device that is still being manufactured. It's the 48T37Y as opposed to the original, which is no longer built. This is a 48T59. Not sure about their numbering. This chip here on the right, I believe is compatible, and this is the one that is in my current design. Um, there are similar chips to this on the market. There's one from Dallas, which I think is the DS1554. I have attempted to try it with the old Sunblade computers, and the microcontroller that interfaces with the clock chip didn't seem to have the timings quite right to be able to set and use the memory on this, at least with the Dallas chip. So we're going to give it another attempt with ST. I actually probably should have done this in the first place, but I didn't actually know that this chip existed until I went looking for it. So anyways, now the 48T37Y comes in one flavor nowadays. It used to come with a dip flavor, but they've gone to exclusively into this, what do you call it? The replaceable battery variant, which is good. Clock chips, if you have a battery, potting a battery is not great for long-term viability. Anyway, so this is a 32 kilobit chip, and the only thing that is outstanding is the original chip, the original clock chip was 28 leads. Okay, this one is 44 leads. Okay, so let's look at some differences between these two products. Okay, so I'll just go through the data sheet. These products were obviously designed at approximately the same time. If we go down to the revision history, here. You can see October 1999 and December 1999. Both of these products were released, so they are I believe they're largely the same design, just with more memory between them. Okay, so the way that you actually pull the time and you talk with the chip is by accessing various memory registers. And let's just compare memory addressing between the two of these, and you'll see that they're largely the same. I believe they'll be compatible. On the older chip, our top address, you'll notice that it is the highest address that you can get out of a 13-bit memory system. Oh, yeah, 13-bit memory system. So that's one FFFF. Of course, that is hexadecimal. And if you look at the things, it's pretty close. So the first byte here stores the year. The second byte stores month. Third byte is the day or the date, as it's written over on the right there. Now, third byte, this is slightly different. Okay, this has some calibration for Y2K, because of course that was a big deal at the time that these were designed. These were, Y2K, air quotes, Y2K compatible. The day of week is going to be the same. The century bit, it's not listed on this other device. This one does it's Y2K compatible. It is obviously Y2K. This is a modern device that's being sold still today. It is obviously Y2K compatible, but they're not worrying about like provisioning for it anymore in the register map. Right. The only thing that I can see that is dramatically different between the two clock chips is the 1000-year entry here and the 100-year entry here. Yeah, it's possible that because it's not present on the original chip that we're going to get into trouble with that. I think we're going to still be okay and our system's still going to be able to run. The day may be wrong at the current next change of century. I'm not actually certain. The controller won't know about these, so yeah, it's a possibility. And that brings us back to my drawing. And so as you can see, we've tied address 13 and 14 together, pulled it up to 5 volts. So these are permanently set to 1. I mentioned this earlier. Yeah, and we're going to put some decoupling capacitors against these just to make sure that give it some stability. I don't know if the increased distance between my design and where the controller is on the original chip is going to cause a problem. But anyways, let's take a look at what I've come up with. Now, the most important thing here is to know that I am on revision 4, and yeah, so basically here we are. Here's our chip. This is the one that we're going to rely on for the time being, the M48T37, and we're going to go down to a connector. This is a surface mount 28-pin connector. I have only picked up the pins off of the 48T37 that I think that we're going to need. This watchdog timer isn't present on the original chip, so I'm just going to ignore it. Yeah, and then everything else is just mapped down to here. Now, I'm going to show you what I've come up with for a design or a little PCB. This PCB does not reflect the current drawing schematic that we've got here. Um, I had done a previous one with a Dallas chip that did not function, but let's give this a shot anyways, and I'll show you what I came up with the Dallas chip, and then I'll have to just redraw it with this different part. Anyways, let's take a look. It's opening up. Okay. All right, so this is my schematic, or at least this is the PCB. Sorry, not the schematic. This is the PCB layout that I came up with for uh, the the previous. This is like a revision 3. Use a Dallas chip. So we have this is the front side of the copper. So the back side of the copper. There's two footprints. The back side has a what are these things? A surface mount dip connector that fits in the socket of the old um, where this will fit in where the socket goes. Let's take a look at the 3D view. Maybe that's the way to do this. Okay, so this is the older design. Okay, so you can see that the IC here Um, this is the Dallas replaceable clock battery. Unfortunately, it didn't work. I did this back in was that June? Yeah, that didn't go anywhere. Anyway, so basically, this is just a surface mount dip connector. I really wish that other vendors for parts like this would use surface mount connectors rather than through hole. Through hole being like it wouldn't have worked at all with this current design because the pins would have gone up into the thing. You'd have had to do some sort of weird. I don't even know how you would have made this work because this is a surface mount component. And if this had been through hole, that wouldn't have worked at all. Anyway, so this is the yeah. What do we have here? The 48T59Y pinout. I labeled it all. Yeah, and this one unfortunately didn't work. I'm going to have to redraw this PCB layout with the M48T37, the one that we just looked at in the schematic. I haven't got to that yet. We'll do that. It's not a problem. I have to get footprints and that kind of thing sorted out. But yeah, we're going to get there probably in the next day or so. But yeah, let's go look at that 3D viewer. So this again, this one here, this one didn't work. The timings were slightly wrong with it. When I went and looked at the data sheets, you know, in hindsight, I can see that there was a few register timings or memory access timings that were slightly different, which I think was messing up the controller. Anyways, so this is the project as it stands today. I have to go, like I said, update the chip that I'm going to use, and then I should be able to get a prototype and we'll test it and we'll see how it goes. But yeah, if you've watched this far, thank you very much. Again, this is a very casual hobby, restoration project that I've been working on. But it's interesting enough that I thought I'd bring people in and share it. Okay, that's all. Bye bye.